He's John Timpane.
And he's Don Rooney.
And this is
The Musical Innertube.
Now, you may ask, why is this podcast called The Musical Innertube?
And we may reply, because that's its name, of course.
Now, how did this podcast get that name?
Back in college, we hosted a radio show. Once, we tried to introduce a soothing musical interlude.
Instead, we messed up and wound up introducing a soothing musical innertube, and the name stuck.
So here we are, hundreds of years later, still talking
to interesting people about their interesting lives.
Difference makers who really make a difference.
Pennsylvania is a state of many firsts, and here's another one to add to that list. The spotted lanternfly was first detected in Pennsylvania in September of 2014.
The spotted lanternfly feeds on a wide range of fruit, ornamental and woody trees, and experts say if they're allowed to spread in the United States, this pest could seriously impact the country's grape, orchard, and logging industries.
So how do we stop the spotted lanternfly? Is there any way to control it? Well, to find out, we're talking today with Julie Urban, who's an associate research professor in entomology at Penn State University in State College, Pennsylvania. Welcome to the show, Julie.
Hi, thanks for having me here. This is great.
Now, Julie, living in central Pennsylvania, just outside Harrisburg, as I do, the last couple of years, you can't walk across a parking lot without crunching a dozen of these little buggers and seeing them flying all over neighborhoods. We're pretty much infested with the spotted lanternfly. How did that multiply in just such a short time? I guess they're prolific little guys or girls, aren't they?
They certainly are. Females lay egg masses, and even though they only lay one a year, there's between 30 and 60 eggs per mass, and we have reason to know that females can lay more than one egg mass. So they're really good at reproducing. And so, but by comparison, when lanternfly was an invasive and showed up in South Korea in 2004, it spread across the whole country in just a matter of a few years. And so if you look at the rate of spread there versus the rate of spread here, even though when you see them, it's really overwhelming, it's been kept a little bit more at bay, or the spread's been a lot slower here than there.
Now, the standard line to all Pennsylvanians from the State Agriculture Department is if you see one, squish one. And they also have instructions that if you see these egg masses on the side of a tree or anything else, to go ahead and, crush them, to scrape them. So I guess because they don't seem to have any natural pests here or any natural enemies, the main way to control them so far has just been to squish the heck out of them. So is that still the standard routine for taking care of them?
Well, yes, that's the messaging and what we want the public to do, but that's not our complete control program. And so the idea there is that it's such a good hitchhiker that if you don't kill it, you'll carry it. And so that's why the public is told your part, what you can do is to keep it from spreading anymore. And so, but in terms of like actual control measures, even starting, as early as 2014, the United States Department of Agriculture, APHIS, Animal Plant Health Inspection Services, and Pennsylvania Department of Agriculture, and now other states who also have lanternfly, they have a pretty solid control program. And so, basically they focus on tree of heaven and treating tree of heaven with an insecticide that's called a systemic. It can get into the plant tissues, and so that when lanternfly feed on it, they're dosed with the poison. And the good thing about that is that because tree of heaven is itself an introduced invasive tree, it's not used by many, natural insects or, who are already here. So it's a little bit safer way to just kind of target lanternfly. They also try to remove tree of heaven, typically with treating it with herbicide. But then also when there's pop-up populations, and here again, government efforts are focused on sites that are at high risk for further spread. So railroad, basically hubs where railroad tracks connect with trucks or ports, that kind of thing, airports. Those are treated with chemical insecticides that knock them down. So there's a whole, complex and pretty sophisticated treatment program. But the focus here, especially because it feeds on grapes and does damage to grapes, right now, even though lanternfly is kind of, throughout the state. It is not yet in the grape growing region in Erie. And even though it's on Long Island and it shows up in the Finger Lakes, it's not yet in the vineyards in Long Island or in those vineyards in the Finger Lakes. And so we really want to keep it that way. And we want the public to kind of buy us time for longer term research solutions to come in. So that's the idea behind that Stomp It campaign.
Now, Tree of Heaven is a preferred place for lanternflies. Do they like that particular plant a lot?
They like it a lot, but they like a lot of things a lot. And so it's
Hungry little buggers. Oh,
exactly.
Boy.
There's over 100 different plant and tree species that are known pests known hosts just in North America. And so Tree of Heaven, though, is from the same native range as lanternfly. And so that might explain the affinity it has to it. But also, if you think about Tree of Heaven, it grows in really disturbed habitats. And so it grows along roadways, it grows along rail lines. And so those are places that if lanternfly travels in your car or on a train and it pops off, it has a great food source. So it lets it establish there. And then also, if you've looked around where you see, lanternfly, where you're seeing them in big numbers and stuff, especially earlier in the season, a little bit before they're adults. If you look at where you see patches of Tree of Heaven, you also have a lot of, often wild grapevines, mulberry, things that are viney and really have, fast growth, and they have a lot of flow and resources. So they kind of like to feed on all of those other plants in disturbed areas too.
So the Tree of Heaven is in itself a pest that was followed by this other pest. So the Tree of Heaven is like a plant pest. Is that right?
Yeah, definitely. And it was introduced here almost 200 years ago because it seemed pretty, And, but since then, it's essentially paved the way, for the spread of lanternfly. And actually, this is something that, this is my first invasive species, so I'm learning these things as I go. But largely what we see is that when you have disturbed habitats, that tends to be fertile ground for other invasive species to use. And so you're familiar with brown marmorated stink bug. It also likes Tree of Heaven and tends to frequent those disturbed areas as well.
And is that stink bug, is that also an introduced species that was not native here?
Oh, yeah, that's an invasive. Yep. And so there, I think I want to point out a really important difference is that even though they're both pests of fruit in a sense, spotted lanternfly just feeds on the plant sap. It can't pierce the actual fruit compared to brown marmorated stink bug that pierces the fruit and does damage that way. This is completely a sap feeding insect.
Okay. So if they go to a grapevine, they feed on the vine itself and not the fruit.
Exactly.
Okay. But that would then in turn damage the entire vine and cause it to shut down?
Yes, and not instantly. And so there, basically what it's doing is, if you look at a lanternfly, its mouth parts are fused into a straw-like beak. And inside that, there's these two tiny hair-like stylets. They're a little bit thinner than human hair. And that's what the insect inserts actually into the plant tissues. And so we're learning in my lab about exactly how it's feeding, but it enters the plant tissues and it'll tap on the xylem, but it'll mostly feed on the phloem. And so there it's robbing the plant of what the plant's making to live, through photosynthesis. And so what's interesting, as I understand it, from some papers that came out from folks at Penn State, Michaela Centenari is our viticulturist and Kelly Hoover is our ornamental person, and kind of the difference between grapes and ornamental trees like red maple is that grapes' defenses don't kick in to protect it from lanternfly, but ornamental trees it does. So lanternfly feeding will reduce photosynthesis if you're a maple or you're a grape, but a maple can kind of wall off and just not allocate resources to that trunk or to that limb and kind of fend off lanternfly. But grapevines really can't shut down lanternfly feeding. And so that, you've seen how large these insects are. They're about an inch long as adults. And when you get, hundreds on a vine and they feed so voraciously that they just deplete, the plant of those resources. And so that's, especially in the late season, those starches are kind of being translocated to the roots that lets the grapevine overwinter. It serves as an antifreeze for it. And so just that robbing just will damage the grapevines over time.
This is such a huge country. We have thousands of shipping containers that come into the country every day. We have people who travel, we're a fairly wealthy country, a very wealthy country. So we travel all over the place. We travel within the United States a lot. You get in the car with the kids and drive. We've already been imagining this invasive species sort of taking a ride, whether inside a car or inside a crevice somewhere so that the wind doesn't bother it or something, and then getting off somewhere else. I mean, it seems like invasive species are always going to be with us, and they're always going to be a pain. I mean, it's so hard to extirpate them, or at least I think a lot of the time it is. And it just seems like this is going to be, just in a wider sense, these invasive species, whether they're plant or animal, because we have invasive plants, a lot of them. I mean, kudzu, if you go anywhere that's fairly warm, kudzu is everywhere. It's on the houses. It's on the people. I mean, it tends to obliterate landscapes and we have a lot of those in the temperate region now as well. And I'm just wondering, I'm sure you thought about this a lot. I mean, I guess it isn't a one size fits all thing. You have to, use different strategies because each of these critters is a little different, but it's an enormous task.
It really is. And what's interesting is that, like the difference between like brown marmorated stink bug and lanternfly, as I understand it, is that, brown marmorated stink bug, when you move something from its native range, you're taking it away from all the other natural enemies. Other insects like parasitoid wasps that lay their eggs in the insect or in the egg or in the eggs, or even diseases, fungi, name it, right? There's a lot of different things that co-evolve, with an insect that keep its numbers in check. And so now you're removing that beastie from all its natural enemies and letting it go wild, right? And so with brown marmorated stink bug, my understanding is that this wasn't, documented fully at the time, but my understanding is that you have some native stink bug pests here they'll have outbreak years every so often, but there's parasitoid wasps that lay the eggs in the eggs of those stink bugs that kind of, it took them a while to recognize brown marmorated stink bug as a stink bug and move over onto that as a food source, but they did. And so you still get those outbreaks of BMSB, but it's a little bit lessened or a little bit more at bay because you have that movement of that natural enemy onto it. Lanternfly is a little trickier because there's not anything really close to it here. We have other native plant hoppers, but plant hoppers in that family, Bulgaridae, that are, what the common name is lanternfly. The closest you get is something in North Carolina. Those are really rare. And so it's just such a different beast that we haven't seen that kind of movement of parasitoids on it, except that's one thing that we're really keeping a handle on, because when it first appeared here, there was the parasitoid wasp that was introduced to control gypsy moth like 20 or 30 years ago. And researchers at DCNR, Hu-Ping Liu in particular, found that this parasitoid wasp was laying eggs in the egg masses of lanternfly. So it was, acting the way we'd want it to. It's just when he studied that, it wasn't a really high proportion of egg masses, and then any one egg mass that was parasitized, not many eggs were parasitized. And so we have some folks from USDA who, I think back in 2014, 2015, immediately went to China to look for natural enemies in its native range. They have 2 candidates that are back here in this high quarantine facility at a USDA site in Delaware, where that's what they do. And they're testing those to try to see if those could be good parasitoids. But in the meantime, as lanternfly is expanding its range, we're keeping an eye out. So I'm leading this big $7 million grant. I have 37 other researchers and a bunch of different institutions. And very recently, we're talking about a database where I rear a couple thousand egg masses in my lab for other things entirely. I'm not working out parasitoids, but the exit hole that a parasitoid will make has a different shape than a lanternfly exit hole. So chuck them in the freezer, and when you have an undergrad can come through and count these things. And we want to keep a collective database across anyone doing anything with lanternfly so that this thing, as it's moving down into South Carolina, it's going to get into the range of different other potential natural enemies. And we want to find it if that's happening. And so I think that could be a promising approach. Keep an eye out on who's out there.
I mean, Don and I will both tell stories about living in California during Mediterranean fruit fly infestations, which have been happening in the States since the late 20s. And there have been dozens and dozens of them. And the state has spent hundreds of millions of dollars against them. And they've had success in tamping down infestations, but the critters just keep coming back. I mean, it's just a matter of time when they resurge, and it just shows you how hard it is to get a handle on these things.
Yeah. And certainly what's been interesting is, like California Department of Food and Agriculture, they sent, folks out in 2018 to learn about lanternfly. They have a very strong, prevention kind of program. And even last week, Pennsylvania Department of Agriculture hosts this thing called the Spotted Lanternfly Virtual Summit. And so it's an update on research and extension. We used to have it in person, but then we can get more attendees. And this was all day last Wednesday, all day last Thursday. And when I was presenting, most of the day, there were almost 500 people online listening. And that's people from other states. So they know what to do, so they're ready. And so they have, for example, other states need to get permission to use the insecticides that are active against lanternfly and have that ready. And so we're hoping, and it really seems to be the case, that these other states are learning from the example of Pennsylvania, and we're sharing all of our information, so that everybody can, the sooner you act, the better your chances are.
I'm thinking back to a story I heard about Australia and the frogs. There was a frog species introduced to Australia to control something else. And once they controlled it very easily, then the frogs went out of control. And now they're all over Australia as a non-native invasive species. So is there a danger in bringing over new pests to control the old pests and finding out that maybe you've introduced another problem into the equation?
Yes, definitely. And so what's been interesting, again, I don't do this kind of work in classical biological control, but, learning and hearing updates from my colleagues over the years, the standard, the criteria that they have to meet before that can ever happen is just tremendous. And so, really there's, U.S. laws and practices. Really, you can't do that unless you know for sure. There has to be a lot of, for example, non-target testing. And so making sure, because in terms of the egg parasitoids in particular, you have to understand what are the chemical cues that they're using to recognize, is this an appropriate prey, and to make sure that they're not going to lay their eggs in anything like silk moths and whatnot. And so that's some of the work that those scientists are working on, is that non-target work. And so it's really fascinating, but I think that the work that they've had to go through has just been really impressive. And so, for example, when they brought back a parasitoid that parasitizes lanternfly eggs in the native range, they brought it back, and again under high containment facility, and what they found was that the timing of the life cycle of that parasitoid didn't match that of spotted lanternfly. And so it's that's weird. And so they kept at it. And basically what they found, and they had to use DNA evidence, they sorted out that there's 4 different they called them biotypes. They're almost like subspecies of this same wasp that looks identically the same. So they sorted out these 4 different biotypes, figured out one that matches it, and each time they have to like feed it lanternfly egg masses to keep this thing going. And now they're doing that target specificity testing. And again, this is something where the biology of these things are little known, but these people have been at it, doing a wonderful job. But they also have a parasitoid that's kind of cool that lays its eggs in lanternfly nymphs. And then this pouch grows out of them and it eats them from the inside when they're nymphs. So like
charming,
really cool stuff. Yeah.
Yeah, that's very cool. Yeah.
Yeah. Cool and disgusting.
That's what we like.
Yes.
That's
cool, disgusting stuff. You just
that kind of describes life, doesn't it?
And it really describes the Musical Innertube podcast, where that's what we specialize in. Don, right?
Cool and
Don's
disgusting.
cool, and I'm disgusting.
We're 12-year-olds at heart, right?
That's right.
Exactly.
That's right.
Well, and speaking of which, this is the first time that I, in my memory, have seen the state take such a proactive, you can help us approach. Because I'll tell you, again, walking across these, the parking lots and the sidewalks that I do during peak lanternfly season, which is, from July through the first frost, there are a lot of squished bugs out there. And I think people have really taken it to heart to every time they see one of these things, step on it. Because these bugs, aren't just laying dead from something else. And they are squished. You could tell somebody put a boot to these things. So that seems to have been very, very successful in getting ordinary people to get in on this and kill it when they see it.
I think the other advantage of that is that, if you look on social media, people are crazy with this bug. It's like everywhere. It's on TikTok and it's an ASMR thing. I forget what the stand for, but people get like soothed when they watch lanternfly get squished. I have no idea. But I think that awareness has facilitated the detection earlier in other states. And so I think that right there is a really, really good thing.
We'll return to our talk with Julie Urban in just a moment. But first, this soothing musical interlude.
Dr. Julie Urban is a research associate professor in the entomology department at Pennsylvania State University. She earned her PhD in evolutionary biology from the University at Albany.
She has been a member of USDA's Technical Working Group of Scientists, advising management and research on the spotted lanternfly since it was first detected in the United States in September 2014. Julie is the lead researcher on a $7 million grant studying the steps needed to reduce the impact of the spotted lanternfly in specialty crops in the eastern USA.
You can read Julie's research papers at that's ento.psu.edu/directory/JMU2, the number 2. You can email her at JMU2, the number 2, at psu.edu.
And now, back to the musical Innertube, already in progress. Now, you mentioned that the spread of lanternflies has been a little bit slower than it has been in other places. Is that a measure of success, or is it just accident, or what can you say about that?
Well, hard to know because that, data hadn't really been collected on that. Basically, I do think that a lot of it is the awareness. I think that there's also, in part, you learn the lessons from people who were less fortunate, right? So we learned from South Korea. We knew what it was when it got here. And so we knew what they did. And so you had said that it was first detected, I think it was like September 22nd, 2014. And basically within 2 weeks from that date, the USDA and Pennsylvania Department of Agriculture established the quarantine and they pulled together a technical working group of scientists from around the country. And so at that time, I was working in the North Carolina Museum of Natural Sciences. I wasn't yet at Penn State. And it was early October when they had this group together and, pulling together, what do you know about lanternflies? What do you know, about all of this stuff? And so they were really, really fast. And so I think that was part of it too.
What is the situation when you're working as an entomologist or anything, and an invasive species that you haven't seen before? You may have heard about it, but you haven't seen it, you haven't dealt with it before, and suddenly it's there and it's reproducing and it's a threat. That sort of chills everybody to the bone, I think. But what does it do to an entomologist? I mean, beside the fact that you're interested in it, what kind of sparks go off in your head when you're confronted with something like this?
I still can't believe it, to be perfectly honest. So I'm an evolutionary biologist by training. And so I happen to specialize in plant hoppers. So lanternfly, or the family Fulguridae, is one of 21 families of plant hoppers. I've traveled around the world and collected lanternflies and other plant hoppers and used their DNA to reconstruct their evolutionary history. And they have these cool bacteria that live inside of them and organs that feed them from the inside out. Like, they're, from a basic science perspective, they're just a bunch of freak show. They're a freak show. And so,
once again, cool but disgusting.
Cool, yeah. And so this family Fulguridae it's about 500 species. This is the only real pest in that group that's known. And it mostly has the circumtropical distribution. And so, I go to French Guiana, go to the tropics, go to Africa, go to Borneo. That's where you get them. And you don't get them in high numbers. And, they're not breakout pests. They're really not a problem. And so we knew about this particular species, like Corma delicatula, because of what it did in South Korea. But like Fulguridae, lanternflies are rare. And so that this thing that's rare could be so ubiquitous here, it still just blows my mind. And so, he's now retired, but the great entomologist at Penn State who is working on this, he joked that even harsh language kills these things. They're very easy to kill, right? A lot of different chemicals work on them. My grad students say they die when you want them to live. They live when you want them to die. That they're just weird critters. And so, the weirdest thing about them is one of the things that makes them so damaging, and it's that they live so long before they breed. And so you figure adults emerge in July, and they're not mating and laying eggs until end of September. And so right there, like, that doesn't make sense that they would live so long before being reproductive. And they're also the only plant hopper that any of us knows about, like guy running the Paris Museum, the people from decades ago. It's the only plant hopper that only has 4 nymphal instars and not 5. This thing has an unusually long adult life that you'd think would make it like, let's just kill it before it reproduces.
I was just going to say that.
Yeah. And I'm convinced that's its Achilles heel. So that's kind of what I'm focusing on. But
so you are working on this very odd sort of time where the thing is adult and it hasn't reproduced yet. And if you could somehow intercept the reproduction, so it's dead before it gets there, that would seem to make some sense as a strategy.
And so, Don, your question, like, what do you think of? Like, this is like, it makes no sense. And like, what is this thing doing? How is it different? How can we get at that? And there's so many different irons in the fire in terms of all the different research angles that people are taking against this thing. And so since, I'm interested in a lot of things with this bug, but my primary interest had been they're called bacterial endosymbionts. They're actually housed in organs inside the insect. And so
are these living things, or is this they're
living
material? Okay. Yes.
They're living things. But what's interesting is that, so like aphids, a lot of sap feeding insects have this. And so they're thought to have evolved or originated as a bacterial infection that then the insect, for whatever reason, creates like a cell wall around it, kind of perhaps to protect its own DNA from this potential pathogen. And so aphids have this, a lot of sap-feeding insects have it. And so if you were to look inside an aphid at these, it's a different bacterium entirely. But if you were to look at this bacterial endosymbiont inside an aphid, and some really fantastic, light microscopy stuff has been done, you would see that there's actually two cell walls. There's like the bacterial envelope and then the cell wall that the aphid creates to contain it. And so hoppers, so plant hoppers, cicadas, spittlebugs, tree hoppers, leaf hoppers, like my group, right? They actually take those cells and aggregate them into actual organs. Huh. And so plant hoppers are the only known animal that have a different organ for each different species of bacteria they've co-evolved with. And so the thing is with these symbionts is that they've co-evolved so long within the insect and they get passed down to the next generation through the eggs that their genomes have essentially rotted away. So basically they're no longer free living. So you can't like smear a lanternfly out and like get these bacteria to grow. It won't happen. And so the lanternfly has 3 different species of these bacteria. And so essentially it's 4 species altogether between the bug and those 3. They all need each other. And so if you look at where the symbionts are earlier in an early adult female, they're kind of wrapped up around the digestive tract, and which makes sense because they're provisioning, at least 2 of them are provisioning amino acids that are missing in the plant phloem. But then as the female develops, like her eggs aren't developed, they're just little ovaries. And so I do a lot of dissections to watch and to try to characterize how, as the eggs develop, what happens is those bacterial organs like kind of, they change color, they change shape, and they literally move and then end up being like strings laying on the eggs so that the bacteria get passed into the eggs. So the complete internal anatomy of a female lanternfly is rearranging during that adult life stage.
That is just so bizarre.
It is just amazing. And so nobody's really characterized this because you can't get enough of the darn bugs, unless you have this kind of pest. I mean, this is like a really interesting opportunity from my perspective. And, but basically, I've tried interrupting it some with chemicals, like softer chemical compounds. So we're still working on that, but also trying to work out, what are the mechanics of that transmission. But as you do this with a new pest where, nothing's a problem until it's a problem, right? Nothing's studied well until it's a problem. What do we know about lanternfly reproduction? Well, there's a paper from the 1930s that has illustrations of the body systems. That's it. So I'm kind of working from scratch here to try to figure out what's going on inside a female as she develops.
Pioneering work.
Now, speaking of the various nymph stages of the spotted lanternfly as it grows older, I had a neighbor who complained about, there's all these these little black things going around, and they jump away the minute you try to squish them or anything like that. She did not connect that to the fact that it was a smaller version of the lanternfly, or because they're black with white spots, and at one point they're red with white spots, and then eventually they grow into the adult. So, is there any thought to trying to helping people identify them in their nymph stages and trying to work with them at that stage to try to eliminate them from actually becoming adults?
Yes, certainly. And that's where people use, if you've seen those sticky band traps that people wrap around their trees. And also there's circle traps where it takes advantage of the insect's tendency at any life stage to, climb up a vertical surface. And so certainly those are useful ways to go, especially if you don't want to spray insecticides, except just want to point out that when you use the sticky bands, which essentially is almost like tape around your tree, you don't want to catch things like birds or things that aren't lanternfly. And so on the Penn State Extension website, there's it shows different modifications you can make that make it so that you don't get those non-targets. There's like little baffles or screens, or cut the tape thinner. So, a larger animal can't get stuck on it. So there's things you can do to be safer there. So certainly you can target the nymphs, but the problem with lanternfly is, as if there were only one. The problem is that they move around so darn much. And so so if you have them in your yard, one day the little nymphs might be on your cucumbers, and the next day they move over onto your roses, and then, they move onto your black walnut. The thing is that, yes, that could be helpful, but, is that if you take out those nymphs, is that going to keep you from having adults in the late season? And no, they're constantly moving around. And so, I think and this is something we're having a research workshop, where we're in April, that's being hosted by New York State IPM and Northeast IPM at Cornell, all about the filling in the gaps and what we're missing in lanternfly research, because, any one study that's estimating dispersal of lanternfly, those are really good studies. But if you think about the constant movement across the whole life cycle, we're really underestimating the true dispersal ability of these bugs. And so, trying to understand, we don't know across its life cycle how far a lanternfly can go, because it's just a constant moving and eating machine. And so if you put up those bands, and we have a study that did this, it banded 20 trees every week. And you see this is how many bugs are on the tree in the egg mass stage. And then you see, it drops down with first instars. And they're changing the band every week. It traps them out. And then doink, you get almost double what you started with when the adults come in. And then you get, 4 times what you started with when the eggs get laid. And so you don't want people to be frustrated. Any little bit can help. But, that constant movement is something to be aware of.
Well, I just wanted to mention the one irony that we haven't mentioned here is that they're actually quite pretty. That they're quite, no, they are. They're quite colorful.
They are.
The wings are very beautiful. The first time I saw one, I didn't know what it was until my wife said, "Hey, you have to kill that." And I said,
"Yeah,
what? Oh, my darling, gentle wife, why would you be so?" And then she squished it. So, kill that thing.
Yeah.
But they are pretty. I mean, you think of toads and snakes and kudzu and invasive species are not really famous for being pretty, snakehead fish. I don't know what else, but wow. They are very, very nice. I mean, it's almost hard to imagine that they would do such, or could, threaten to do such damage.
Yeah.
I never liked insects until I met plant hoppers. And that was it. I call them my gateway bug. They're what'll take you into insects, because they're beautiful. They're so interesting. They have bacteria and organs.
Yeah, they're cool and disgusting.
It's you live in a cool and disgusting world, Julie Urban. Thank you for making it available to us today on the Musical Innertube. We really appreciate it.
Sure thing. Thank you.
Yeah, thanks, Julie. And remember, everybody, you see one of those beautiful things, squish it. And thank you for listening to the Musical Innertube.
The Musical Innertube is available everywhere good podcasts are found. Listen on your favorite platform and give us a good rating.
You can subscribe to the podcast on our website, musicalinnertube.com.
There you can listen to all of our podcasts, see pictures and biographies of our guests, and contact us. You can even leave us a voicemail.
And don't forget to leave your email address on our Talk to the Two page on the website, and we'll send you a preview of who's coming to talk with us by email, just so you're prepared.
That's musicalinnertube.com.
And as always, thanks to virtual band Car Radio Dog for our theme music.